Hi everyone, my name is Wendy and my partner Kristie and I will be presenting our project on predicting prices for used cars. The motivation for our project is, are you being overcharged for a used car? And basically used car purchase tends to be the most financially smart decision for first-time car buyers. However, because of the risk of being overcharged for a used car, it often requires a lot of research and digging into how like other used cars have been sold. And so the goal of our project is to predict the price of a used car by looking at select features of used cars across multiple dealerships, as well as comparing different methods of predicting the price. And the data set we used is pictured here, and the features that we considered important for selling price prediction were year, mileage, number of previous owners, the model and make, engine, and power. And so for our data, we had 1,982 unique car model and make, and 7,906 values after we dropped 1,100 null values. And for our approach, we decided to use regression because we are trying to predict a continuous dependent variable of selling price, which is explained by numerical independent variables such as year, mileage, and number of previous owners. And we decided to compare linear regression and KNN regression. So some of the characteristics of linear regression are that it assumes a linear relationship between the features and the selling price. And we can look at the coefficients to identify the most relevant features. And for our project specifically, we found that the unregularized model actually performed better than the regularized model. And the characteristic of KNN regression is that it performs better than regular regression when there's less noise in the data. So the first step of our project was pre-processing, and this included things like extracting the target column from the original data set, as well as removing irrelevant columns such as torque and seller type. We then changed categorical attributes to numerical ones, such as changing the car name, which was originally a long string, to just the brand of the car, and then two binary attributes. And we also changed some string typed attributes into integer and float values. We then scaled our data using standard scalar, used train test split to split the training data and test data into about 2/3 and 1/3. And then we created a correlation matrix for the attributes of the training data to see if there's any correlation between any of the variables, but we found no strong correlation.
So one of our approaches was using linear regression to determine if the features we were considering have a linear relationship with the selling price. And we decided to test regularized and unregularized regression models to see which model gave us the best prediction. And to compare the models, we looked specifically at the mean squared error. So first we used lasso regularization to fit our training data. And to determine the best hyperparameter, we used a fivefold cross-validation method, and we found that the best hyperparameter for the alpha value was 0.001, and lasso gave us a mean square error of 9.83. And when we used the same cross-validation method for ridge regularization, we found that the best hyperparameter was 0.6, and this gave us a mean squared error of 9.85. And we also looked at the unregularized linear regression, and we found that the MSC gave us 9.28, which was lower than using the regularized models. We also built a KNN regression model, and we used fivefold cross-validation as well. And we found that the best hyperparameters was using distance and 6 neighbors. And we got a much lower MSC value than using regression, and we got a value of 2.117. And we can see on the right that there's a graph for actual price versus predicted price, and we can see that KN regression has a much more linear relationship between the actual and predicted price than linear regression. So overall, our results was that KNN regression performed better than standard linear regression, even though linear regression performed better than unregularized linear regression performed better than regularized. We also found that dropping the null value in general gave us a better prediction than replacing them with 0 or -1. And we found that using model and make instead of filtering on brand would still give us an MSC of around 2.12 for KN regression, even though regularized models would perform better if we were to use the model and make combination. So in our case, KN regression performed better when we filtered on, like around the same when we filtered on brand. So filtering on brand gave us a good enough prediction. Thank you.